All right, let's dive in. So, we've all gotten pretty used to AI that can chat, write, and even whip up images. But the next wave is already here. We're talking about AI that doesn't just talk back, but actually does things. Today, we're breaking down how to build this next generation of AI, agents.
So let me ask you this. What if AI could do more than just talk? I mean, we're used to chatbots that just kind of sit there waiting for us to type something. But imagine giving an AI a goal, like plan my weekend trip to the mountains, and it doesn't just spit out a list of ideas. It actually books the cabin, it checks the weather forecast, and it maps out the driving route, all by itself. And that right there is the huge shift we're talking about. We're moving from AI that's basically a really smart parrot, just responding to us, to AI that's proactive, that's autonomous. And trust me, this isn't just a tiny update. It's a whole new ballgame, a new category of AI systems that we call agents.
Okay, so what is an agent really? Well, at its core, it's a system that gets tasks done for you, all on its own. The big difference from a chatbot is that an agent has both the tools and the smarts to see a whole workflow through, from the very beginning to the very end.
Right? So this all sounds great, but when would you actually need an agent instead of, a simpler tool? Because they're not for everything. You got to think of them as the specialists you call in for the really complex jobs, the ones where your typical automation just throws its hands up.
This is a great way to think about it. A regular old automated system is like a security guard with a simple checklist. Is the name on the list? Yes, go ahead. But an agent is more like a seasoned detective. It can look at the whole picture, pick up on weird little details, and make a judgment call, even when the situation is fuzzy.
So knowing when to deploy one of these is key, and it really boils down to three main scenarios. First, for complex decisions that need real judgment, like a tricky refund request that isn't black and white. Second, when your old rule-based system has become this giant tangled mess that nobody can update anymore. And finally, when you're just drowning in unstructured stuff like thousands of customer emails or support chats, and you need something that can actually read and understand it all.
All right, so we know why we'd want an agent. Now, how in the world are they actually built? The best way I found to think about it is like you're building a little robot employee for a specific job. It needs a brain to think, hands to do stuff, and a rulebook to follow. And those three things are the core components. First up, you've got the model. That's a big, powerful, large language model, and it's the brain. It does all the reasoning. Then you have the tools. These are the hands. They're basically functions or APIs that let the agent interact with the outside world, to send an email or look something up in a database. And last, you have the instructions. That's the rulebook. It tells the agent what its goal is and what it can and can't do.
Now, I know this might sound super complicated, but check this out. The actual code to get started can be shockingly simple. Take a look at this snippet of Python here. We're literally just defining an agent, giving it some basic instructions, be a helpful assistant, and then one single tool, get the weather. That's all it takes to get started. The real magic happens when these simple pieces start working together to do some really powerful autonomous things.
Okay, but this is where it gets really interesting. When you start to scale, you can have one agent that's kind of like a jack of all trades, or you can build an entire team of specialist agents that all work together. And getting them to work together, that's a super important concept called orchestration.
So, you've basically got two main flavors here. On one hand, you have your single agent systems, one model, one workflow. Great for a lot of tasks. But on the other hand, you have multi-agent systems, where you split the work up among a whole crew of specialized agents. It's kind of like the difference between hiring a solo freelancer versus a whole creative agency.
So if you've got this team of agents, how do you make sure they don't step on each other's toes? Well, that's where orchestration patterns come into play. There are two main ways to set up this teamwork. The first one is called the manager pattern. Pretty straightforward, right? You have one central manager agent who's the boss. It gets the main task and then delegates little pieces to its specialist agents. The other way is the decentralized pattern. Here, the agents are more like peers. A triage agent might get a request, figure out who's the best agent for the job, and then just hand the whole thing off. And these diagrams here show it perfectly. Look at the left, the manager pattern. A user asks for a translation. The manager agent gets it, then calls on its Spanish, French, and Italian specialist agents to do the work. It's the central hub. Now look at the right, the decentralized pattern. A customer asks, "Where's my order?" That goes to a triage agent, which says, this is a job for the orders agent, and passes it on completely. So you can see the trade-off, right? It's either centralized control or distributed independence. Okay, let's talk about maybe the single most important piece of this puzzle. When you build something that can actually do things in the world, you absolutely have to make sure it does them safely and predictably. And that is where guardrails come in.
And I really like this way of thinking about it. It's not about having one single safety on switch. It's about having layers of defense, with each layer designed to catch different kinds of problems before they can cause any trouble.
Yeah, this diagram looks a little intimidating, I get it. But the main idea is actually really simple. A user's request doesn't just go straight to the agent. Let's follow the path here. The input comes in, and right away it has to get through a whole series of checks. First, an LLM classifier looks for anything dangerous. Then it hits some hard-coded rules. Then it might get checked by a moderation API. Only if it passes through all of those checks is it ever allowed to actually trigger an action.
So what are all these different layers? Well, they each have a very specific job. You've got classifiers that make sure the agent stays on topic, and others that sniff out attacks like prompt injections. You got filters that block sensitive personal info, that's PII. And crucially, you have tool safeguards that literally rate how risky an action is before the agent is even allowed to try it. Every single one of these is a critical line of defense.
And here's the thing. Building good guardrails isn't a set-it-and-forget-it kind of deal. It's a process. You have to start with the basics. Data privacy, content safety. But then, as it's out there in the real world, you watch for when it messes up or hits weird edge cases, and you build new guardrails to handle those situations. It's this constant loop of testing, learning, and improving.
So if there's one thing to take away from all this, it's that agents are a huge leap forward. We're going way beyond just having a conversation with an AI. We're now building systems that are designed from the ground up to reason, to use tools, and, most importantly, to actually act and solve real complex problems. Look, this technology is moving at a breakneck pace. It's opening up some absolutely mind-blowing possibilities. But it also forces us to ask some really big questions about control, about safety, and about who's responsible when things go wrong. The agent is coming. There's no doubt about that. The real question we have to ask ourselves is, are we ready for it?